Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so our last class we have stopped at chapter 2, which is Sarrus'Rule, if I'm not mistaken. So today we proceed with chapter 3. So we start with determinants. Okay, so you can refer to your textbook later. So I just give a brief explanation about chapter 3 on the first topic of determinant. Okay, so determinant, it is only applicable for square matrix only. If you still remember square matrix, where you have your number of column equal to number of rows. Okay, so if you look here, for A, so for this one, it is in the form of matrix, either square bracket or just bracket like this one. So this is the square matrix. However, for determinant, we are going to use this modular sign. So this means it is a determinant and it is only applicable for square matrix only. Okay, so how to find your square matrix? So you have to know that how to find your determinant. Okay, so there are a few methods to solve this determinant. So the first one, if it is 1 times 1 matrix, so this is the easiest one. So if the matrix 1 times 1, for example, matrix A, the D element is negative 5, so the determinant is also the element. So it does not become modulus, maknanya dia tak jadi positif lah. So determinant is equal to the element. So next one is B, which is element is 4, so determinant is also 4 lah. Okay, so if it is 2 times 2 matrix, so we have a formula here, 2 times 2 only. So to find determinant of A, which is let's say A, B, C, D, so determinant is equal to AD minus BC. Okay, so which one is A? A times D times minus B times C. So if you look at this first example, okay, so B is equal to 1, 5, 3 minus 1. So determinant is 1 times minus 1 minus, always minus 5 times 3. So it is cross angka ni. So this is negative 16. Okay, it is special for 2 times 2. And then another one special for 3 times 3 matrix. This is called the Sarrus'Rule. Okay, quite complicated here. So what does Sarrus'Rule means? So first, the matrix is in black pen here. So this is the original matrix. And then apa yang you buat adalah you copy balik row yang kolom pertama dan kolom kedua kat belakang. Okay, so here first column, and here is your first column, second column here. And then to get your Sarrus'Rule, the formula is S1 minus S2. So S1 you start from the top, this one, 1 times minus 2 times minus 5. So you get this one. Okay, 1 times minus 2, 1 is 5. Next one is 2 times minus 1 times minus 4. This one. And last one is minus 3 times 0 times 0. So solve this one, you get minus 18. Okay, and then next one, terbalik pula daripada top right. Tadi top left, ni top right. So dia daripada S2, sini turun bawah ni. Here, here and here. Okay, so it will be, okay, so the first one 2 times 0 times 5. Lepas tu 1 times minus 1 dan 0. Minus 3, minus 2 and minus 4. So you get this one. So your determinant will be minus 42. You can refer to page 94. Okay, these are one example. You can try for your try on your own. So we have entry A here. Okay, so we write in the form of Sarrus'Rule. Okay, so kita copy balik kolom pertama, kolom kedua. So to get your S1, this one then, minus 2 times 3 times 0, so 0 lah. 1 times 1 times minus 1, minus 1. Ada 0 je, terus jadi 0. Okay, S2, daripada top right, 0. Minus 2 times 2 minus 4, and then 5 times 3 minus 1 is minus 15. So you get determinant is equal to 18. Okay, so cara yang seterusnya, this one is panjang sikit, cofactor expansion. Okay, so cofactor expansion ni it applicable for any square matrix. So dia lebih sikit. Kalau you tengok tadi, kalau 1 times 1 matrix, so you just take the element. 2 times 2 matrix, just find AD minus BC. And 3 times 3 matrix, you can use Sarrus'Rule. However, dia ada limited. Kalau matrix tu 4 times 4 ke apa semua, dia tak boleh, you cannot apply the method. So these are the general method, cofactor expansion. Cofactor expansion ni any square matrix, 3x3, 4x4, 5x5. Okay, but first, before you do the cofactor expansion, you need to find the minor. So what does it mean by minor? You have to find all the elements. So here is M11. So to get your M11, you have to close all the, this one and what we call this, the row and also the column. So M22, M23, M32, M33. So you get this one. Saya tutup first row, saya tutup first column. So yang 3, 4, 5 nanti 4, 3. Okay, tapi tak letak sign lagi. Okay, so you use AD minus BC here, get 32. Okay, next one is row pertama, kolom kedua. So tutup row pertama, tutup kolom kedua. So yang tinggal 0, 5, 6, 3. So dapat yang kita 30. Dan seterusnya lah sampailah dapat semua sekali ni. This is called the minor. So susah kan, banyak kerja. Tapi dalam final dia takkan suruh cari semua. Dia mungkin kurangkan 1 atau 2 je lah kan. Okay, lepas tu how to get your cofactor. This is on page 96, definition 2. So cofactor ni senang je. What you do is you just follow the sign. So dia macam ada pattern lah, tambah, tolak, tolak, tambah je. Tambah, tolak, tambah, tolak, tambah, tolak. So dia alternate. So daripada yang tadi tu, yang ni minor, this one is the minor. So when you put the sign here, this one, dia jadi cofactor. So this is called the cofactor matrix. So tambah, tolak, tambah, tolak, tambah, tolak, tambah, tolak, tambah. So you get your cofactor matrix here. Okay, so after you get your cofactor matrix here, so we apply the theorem of cofactor expansion. So it can be, you can refer to page 98. Any, what we call this, any value, any square matrix. So determinant for A can be calculated along any row or column. Maksudnya you pilih row mana pun, column mana pun, jawapan dia sama. Tapi selalunya we choose any row or column which involve the least amount of calculation. Maknanya yang paling banyak zero lah. Tak semestinya zero. Kadang-kadang kalau elemen dalam matrix tu tak ada zero, nombor 1 pun boleh juga. So yang mana yang paling senang lah kan. Okay, let's have a look at this example. So we have a matrix A. Okay, lepas tu we want to apply the cofactor expansion. So bila kita pakai cofactor expansion, let's say we use row yang kedua. So why we choose row second row? Because we have zero element here. So kita terus, kalau ingat yang tengah-tengah ni adalah method untuk dapatkan minor. Lepas tu bila kita letak sign, dia jadi cofactor. So kita combine dua-dua ni jadi cofactor expansion. So you can try for the along second row. So you close your second row and you close your first column. So the element first is 0. So sign is negative sebab dia row yang kedua. So 4, 2, minus 7. And then second element is 6 sebab yang kedua ni adalah positif. So positive 6 and so on. So you get 15. Okay, kalau guna first row, first column pun sama juga, dapat jawapan 15. Okay, lepas tu sebab soalan ni adalah matrix 3 times 3 matrix, so kita boleh juga pakai Sarrus'Rule. So Sarrus'Rule will also get 15. So actually, kalau 3x3 matrik sama ada pakai Cofactor expansion atau Sarrus'Rule. Kalau final selalunya untuk soalan yang chapter 3 ni dia akan mention method apa dia nak. Tapi kita akan also apply, we will also apply this method at chapter 4, 5 and 6. So yang tu up to you lah. So sama ada nak pakai Sarrus'Rule atau Cofactor expansion. Okay, so this will be the rest of example. Okay, ni special sikit. Kalau determinant tu untuk triangular matrix, can refer to page 100. Okay, contoh yang ni apa triangular, so kita just ambil diagonal je. So minus 9 times 2, so minus 18. Macam yang ni 3 times 3 matrix. So determinant 3x minus 2 4x and so on lah. Okay, so these are the rest of the example. Okay, so untuk minggu ni kita belajar sampai ni je lah, Cofactor expansion untuk first class. So nanti saya akan ambil lah, dan beberapa contoh soalan nanti kita akan discuss dalam kelas ni kan. Nanti saya akan ambil lah dekat ada di kelas kan. Okay, so thank you very much, see you again.